rematch of the NCAA Men's Volleyball Championship between Yale and North Carolina.
If you're just joining us, it has been a roller coaster of an evening. Both teams now tied at 2 sets apiece. The winner of this final set will be the national champions.
North Carolina leading by 1. Yale and their team captain, Scott Sterling.
Love that man.
Don't we all? Trying desperately to hold them here, or it's all over.
Match point for the Tar Heels. Jones preparing for what may be the last serve of his college career.
And here we go.
Excellent serve.
And setting up. Here comes the spike.
Yale has to stop this return or else... Oh, deflected! Right to Scott Sterling's face.
And Yale ties it up.
Unbelievable.
Buckle up, ladies and gentlemen, because Scott Sterling's face has entered the building.
Take a gander at this replay.
The angle at which Sterling deflects the ball off his skull is nothing short of perfection.
Like watching Da Vinci paint with his face.
Yale now on the prowl to take the lead.
And Carolina setting up what is bound to be a devastating return. And here it comes.
Sterling makes another tremendous save.
And North Carolina's wasting no bother on foul.
Sterling scores.
Welcome to the heavyweight bout between Sterling's face and everything else.
He looks as though he could be praying.
The peaceful visage of head trauma.
We are all witnesses.
Testify.
Let us feast on the sweet nectar of instant replay.
Wonderful save here, just complete
The
sacrifice.
ball flies right past the blockers, into Sterling's awaiting face, back over the net, and then right back to Sterling's face like an obese homie pigeon.
That man will leave this court today knowing he gave everything he could, if he leaves it all.
The crowd is now on their feet.
Like mythical Atlas who bore the weight of the world upon his back, so too has Scott Sterling bore this team upon his face.
Yale has come back from the brink and is looking to put this one into the history book.
That's point for Yale.
Did Carolina finally push one through Sterling? Proud Sterling!
Did you see that?
Here comes the spike straight to the man!
The man!
The legend! His teammates help him to his feet. Now they raise him heavenward.
He ascended through the air like a defensive angel!
An angel with the face of a devil!
Look at this replay! One is the loneliest number!
2 tickets to paradise!
3 times a lady!
Forever young! As the crowd charges the court, the people are weeping!
Here's the John!
The tweets are tweeting!
That's that cup!
Alright, guys. I don't know why that is absolutely fun. I figured that you guys would appreciate that to kickstart these notes off. So, okay. Properties of logarithms. Yesterday we began to talk about logs, and so today we're going to continue with it. Daily questions, log base 2 to 32. If it's asking you to find these, I'm going to put x in here to start off with. Remember, it's base of your log raised to the exponent, 2 to the x equals 32. So 2 raised to what power gives me 32? That's just 5. You can play around with it. Base of your log raised to the exponent equals 1/9. Alright, to make something flip, your exponent has to be negative. And then, what do I have to raise 3 to the power of to get it to turn into 9? Well, 2. So my answer is negative 2. Now this one, again, base, raised to the exponent equals 1/5. Okay, a lot of people were asking about this question yesterday in homework. So to make it flip, it needs to be negative, and to make something go from 125 to 5, you have to raise it to a fraction power, keeping in mind that the fraction power stands for the root power. Okay, 1/2 power stands for square root of x, 1/3 power stands for cubed root of x, so on and so forth. So what root of 125 turns into 5? Well, the third root, meaning the cubed root rather. Okay, cool. So let's take a look here. We do have a change of base formula. Let a, b, and x be positive real numbers such that a cannot equal 1 and b cannot equal 1. Then log base ax can be converted to a different base as follows. If it's base b, okay, what we can say is log base b of x. So you write log base b of x. We can convert that and make it into, if I want to make it into base 10, what you do is you take just the normal log base 10 of x, the top one, and you divide it by log 10, okay, of b, the bottom one. Alright? I can also do that for log base e, which is natural log of x over natural log of b. So where this allows us to help out is that if I gave you guys an example like this, log base 4 of 30, oops, pardon me. What you can do, evaluate and check using base 10. So I can rewrite this as log 30 over log 4 because I have this on the calculator. So if I have my calculator here, I can do log 30, close it, divided by log 4, close it. And it says use round to 3 decimal places, so 2.453. Alright? Because I couldn't put log base 430 in my calculator, I have to do this conversion first. So over here I can do log of 14 over log of 2. Okay. And that gives me 3.807. Alright? So I can also do this with natural logs. Now if you'll notice, please check this out, it's the same exact problem, but notice that instead of doing log, which is base 10, I'm going to do natural log, which is base e. Natural log of 30 over natural log of 4. Let's check out and see what happens here. So I'm hitting my different button, natural log of 30, close it, divided by natural log of 4, close it, 2.453. You'll never guess in a million years what I get over here. Natural log of 48. I'll write that out for you guys. Close it, divided by natural log of 6. We get 3, oops. Oh, it's a different problem. I'm sorry. So 48 divided by log 6 would give you 2.161. I was thinking it would be the exact same thing at the top. Alright. So log or natural log, it will work out. Okay, this is one of my all-time favorite things in all of Algebra 2 because it's kind of like solving puzzles. Alright, so check this out. Properties of logarithms. Let a be a positive number such that a cannot equal 1, and let n be a real number. If u and v are positive real numbers, the following properties are true. Log base a of u times v. You can rewrite it as log base a of u plus log base a of v. If I have two things in here multiplied together, you can split them apart by addition. So this is your puzzle key, if you will. Okay, multiplication you can break apart by addition. Division I can break apart by subtraction. So log base a of u over v is equal to log base a of u minus log base a of v. Let's check this out. If I have a power raised to a power, what you're allowed to do is take the exponent and throw it out front. N log base a of u. Okay? This will make sense in a minute when I show you guys a few example problems. It's the exact same properties over here. So you see how it's natural log of u times v? It's just natural log of u plus natural log of v. For natural log of u over v, it's natural log of u minus natural log of v. And then what I can do again is you can take your exponent and throw it out front. N natural log of u. So please make sure you guys have this jotted down. Important. Even Scott Starling said it's important. Okay? He always uses his head. Ha! Get it? Because he uses his head. I'm done. I'm sorry. Okay, so now, example 3, we want to write each logarithm in terms of natural log of 2 times and natural log of 3. You'll see why more in the homework, but so I want to find a way to rewrite 6 in terms of 2 and 3. So what can I do with the numbers 2 and 3 to get 6? Well, you can do multiplication. So I can do natural log of 2 times 3. That's equal to 6. And then like we just talked about, what you're allowed to do is natural log of 2 times 3, multiplication you can break up with addition. So natural log of 2 plus natural log of 3. And there you go. You've rewritten it as a natural log of 2 and 3. And basically you want to have each number have its own natural log or log in this case. So here, natural log of 3 over 2, we just talked about division you break up with subtraction. It's natural log of 3 minus natural log of 2. I'll throw prints around. You don't have to put prints around. I started it. I might as well continue with it. This one's a little tricky. How can I rewrite 4 and 27 in terms of 2 and 3? Well, I can rewrite 4 as 2 squared. And I can rewrite 27 as 3 cubed. So again, it's division. I can do this. Natural log of 2 squared minus natural log of 3 cubed. And then exponents you can throw out front. So 2 natural log of 2 minus 3 natural log of 3. Trust me, you're going to get very, very good at these in just a few days. Okay? So there we go. Alright. This is where it really comes into play, the next two examples. And I love these problems. I love thinking of them as as puzzles, okay? And you'll see what I mean in a minute. Log base 4, 5x to the third y. I want to expand it. I want to make it bigger. So I want each of these things. I want the number to have a log, I want the x to have a log, and I want the y to have a log. So check out what we do. Log base 4 of 5. Multiplication you break up with pluses. Log base 4 of x to the third. Plus log base 4 of y. And then after you've broken it up, you check to see if there's any exponents. There is, right here. So I can rewrite this as log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. And there you go. Each term, my 5, my x, and my y, each has its own log. It's kind of neat. I just like the way those are breaking up. Here, I can rewrite this as the square root of 3x minus 5 is the same thing as 3x minus 5 raised to what power? Oh man, I hope somebody here can say 1/2. Yay! Over 7. Now it's division, so I have natural log of 3x minus 5 raised to the 1/2 minus natural log of 7. What do you do with exponents? You throw it out front. So I got 1/2 natural log of 3x minus 5 minus natural log of 7. Now before someone kind of asks this question, well, can we keep breaking this up? This is a quantity that's all under the square root. So therefore, that's it. If you ever have anything under a square root or raised to a power, you leave it together. Okay? So this is called expanding it. Now, I'm sometimes going to ask you guys to condense it, which means I want you to put everything under just one log. So we're going to work in reverse. If it's out front, that stands for its exponent. So it's log x raised to the 1/2. Okay? Plus log the quantity x plus 1 raised to the third power. Alright, because I just put the exponents back up. What does the plus sign mean in reverse? It means multiply. So it means log x to the 1/2 times x plus 1 cubed. One last thing. What does the 1/2 power stand for? It stands for square root. So square root of x times x plus 1 cubed. Ta-da! Awesome sauce. Okay? So notice how we went from having each of the things have its own log, now we just have one log with everything underneath it. I love these problems. I don't know why. I love these problems. They're fun. Part B, the 2 is your exponent. Natural log of x plus 2, the quantity squared, minus natural log of x. Okay? What does minus mean? In reverse, it means division. So natural log of x plus 2 squared divided by x. That's it. Okay? Oop, forgot to box this one off. Alright? So that's all she wrote. Alright? If you have any questions, feel free to ask. The homework has a lot of practice problems on it. Use your notes. Okay? So if you come up and ask me for questions, that's totally fine. But I'm going to be like, where are your notes at? Because I want to point out to you guys these properties. Okay? So as always, keep up the good work and good luck. We are all counting on you.